back, students. Today I'll go with chemistry session. I've covered all the topics of your first chapter, that is chemical equation, combination, decomposition, displacement, and double displacement, and the redox reaction, which is the last one, corrosion and rancidity. So these three topics I'm going to cover today. I just want to make one recap. First is combination reaction, in which the two simpler substances combines to form complex substance. Clear? That means two simpler substances, when they are combining to form the complex, is known as combination. Decomposition, when the complex substance breaks down to give the simpler substance, then it is decomposition reaction. Displacement reaction, when the high reactive metal displaces the low reactive metal. I have already given you that reactivity series, in which you have to trace which one is high reactive and which one is low reactive. So high reactive will displace a low reactive, but low reactive will never displace the high reactive metal. Right? Double displacement, also known as precipitation reaction, in which the exchange of ions takes place between two salt solution, and precipitate is formed, which is the insoluble substance collected at the bottom of the test tube. One is insoluble solid particles and other is soluble. So in double displacement, always the colorful precipitate is formed. Clear? So maybe white, maybe, that depends upon the reaction which you are doing. So what happens? The PPT is formed. And next, the last one is redox reaction. Now come, students. Redox reaction, it is a combination of two words. See, if I say oxidation and reduction. Now, reduction. These are the two terms we have to understand first, and we are taking red, that is reduction, and redox, reduction and oxidation. Now redox reaction, most of the reactions in chemistry comes under this category. That means when the reduction and oxidation takes place simultaneously in the same reaction, then it is known as redox reaction. So first let me give you one clue what is oxidation, what reduction actually is, and then I'll continue with this reaction. Right? Shall I start? Come. Now oxidation, as the name suggests, oxygen. Oxidation means addition of oxygen. Addition of oxygen. This is the first point. Whenever in any reaction the oxygen is added, that means we are talking about oxidation reaction. Another word, another statement, that means if addition. And if I say the removal of hydrogen, if I say removal of hydrogen, then also it's the same meaning, that is oxidation. And if hydrogen is removed, the third concept is also there, that is the removal of electron. Removal of electron is also comes under oxidation. Then what is oxidation reaction? It is addition of oxygen, removal of hydrogen, and removal of electron is there in the reaction. That means this is oxidation reaction. Reduction, opposite, just opposite to that. Here, first step is removal of oxygen. Addition of oxygen is oxidation, removal of oxygen is reduction. Second, addition of hydrogen. Say, student, just opposite to that of oxidation. Addition of hydrogen. And if there is addition of hydrogen, here removal of hydrogen, removal of electron. Addition of hydrogen, then the third point, yes, students, addition of electrons. These are the 3 points which has to be kept in mind when the oxidation and reduction goes. Suppose, for example, I am giving you, if I say C plus O2, carbon, when reacts with oxygen, so oxygen is added to form CO2. That means this is oxidation reaction, when oxygen is added to the carbon. Clear, student? What is oxidation reaction? If I say H2 plus O2 gas, hydrogen plus oxygen gives water. That means what happens? Again the oxygen is added to the hydrogen. Gives water. This is what? Oxidation reaction. If I am talking about reduction reaction, then if I say ZnO plus C gives Zn plus CO. See, very simple, student. Here what happens? Zinc oxide is removing its oxygen and giving it to carbon. So zinc oxide is doing reduction. Why? Because the removal of oxygen is there. And carbon is gaining what? Carbon is gaining oxygen to form carbon monoxide. That means it is oxidation is going on. This is how reduction and oxidation takes place. These are the single reaction where I have shown you. Now the reactions which I am going to show you, that is when both the reactions are going, both the processes, that is oxidation, reduction, are going simultaneously to show the redox reaction. Suppose if I say Cu plus hydrogen gives copper plus water. Yes, student. Here what happens? This is losing its oxygen and hydrogen is gaining. So copper oxide is oxidation or reduction? Yes, reduction. Doing reduction. And hydrogen is gaining this oxygen. So hydrogen. And whenever we are tracing all this, it should always towards the reactant side. Nothing to do with the product side. Here, oxidation is being done by copper oxide, that is reduction, and oxygen is gained by the hydrogen here to form water. That means oxygen is added, that is water is formed. So this is known as redox reaction. Clear, student? When both the reactions are simultaneously going, copper oxide losing its oxygen. Removal of oxygen means we are talking about reduction. Addition of oxygen means we are talking about oxidation. So reduction and oxidation is going on simultaneously. Suppose if I take another example, ZnO plus C gives Zn plus CO. Now oxygen is removal of oxygen by zinc oxide. That means it is doing reduction. Oxygen is added to carbon to form carbon monoxide gas. So oxygen is added means oxidation. Very simple, see, nothing is there. Only you have to trace which is removing and which is adding up. That shows redox reaction. Both the reaction, most of the reactions comes under redox only. Suppose third example, in our NCERT it is there, MnO2 that is manganese dioxide plus hydrochloric acid gives MnCl2 plus water plus chlorine gas is released out. Chlorine gas. Now here what happens? Magnesium oxide, if I am talking about, it is losing its oxygen. Removal of oxygen and it is giving it to hydrogen to form water. See, very important. MnO2 is losing its oxygen to HCl. So MnO2 is removal of oxygen means we are talking about reduction. Here chlorine, hydrogen is gaining this water. That is, hydrogen is gaining oxygen to form water, and that means hydrogen chloride is what is happening here? The oxygen is added here. That means what is going on? Oxidation to form water. So chlorine is doing oxidation. Chlorine is oxidizing, oxidation it is doing, and the chlorine gas is released. We have to balance it. Here we have to balance to get 4HCl, 4Cl, that means 4. Chlorine gas is released. Here MnO2 is doing reduction and chlorine is doing oxidation from HCl, and it is removing and then removing of electron. That means chlorine is removing here. In concept of electron, if I say chlorine is removing here and the oxygen is added, that means chlorine is oxidized. Clear, students? This is how the redox reaction could be done. Next one step is there, I think not in our NCERT, but still you should know. Now here copper oxide is providing oxygen to the hydrogen. right, to form water. That means it is providing oxygen. It is helping in oxidation reaction. So that means it is, and itself it is getting reduced. Itself it is getting reduced. So removal of oxygen, providing oxygen to the water, itself it is reduced, which is reduction, and it itself is becomes oxidizing agent. This is agent. Agent means providing. Why it is called oxidizing agent? Because it is providing oxygen to hydrogen to form water. So itself it is reducing, that means reduction is going on, and it is known as oxidizing agent. Here hydrogen. Now here, if reduction is oxidizing agent, then oxidation means we are talking about reducing agent. Means gaining that. What is oxidation? Is gaining of oxygen. Clear? So when it is gaining is going on, then itself it becomes reducing agent. So just opposite, if it is just a simple trick is there. If the reduction is going on, then we will call it as oxidizing agent. If oxidation is going on, then we will call it as oxidizing agent. That much is only in your syllabus, but higher classes will come to know about all this. Now this is redox over. Next topic is corrosion. What is corrosion? Already 8th or in your previous classes you have studied about corrosion. It is the spoilage of the metal in presence of oxygen, moisture, or any attack of acid. So what is corrosion? If the metal is attacked by oxygen from the air, moisture from the air, or any acid attack, then we will, and the originality of the metal will change, and the product which is formed, which is of no use. So for that we have to prevent it. I'll continue with. So what is corrosion? When the metal is attacked by oxygen, water, or any acid, then it becomes corrode and known as corrosion. For example, if I say first corrosion example is iron. Suppose iron is reacting with oxygen of the air to form Fe2O3. And Fe2O3 when reacts with water, that means during rainy season especially, if I am talking about it is reacting with moisture, that is water only, it will form Fe2O3 dot X molecules of water will stick to it, and this is known as rust. X means any number of water molecule will stick to this iron oxide, forming the rust, which is a reddish brown color substance. So this is the final product of Fe2O3H2O. This is the formula of rust, and iron shows rusting. Now corrosion and rusting is not the same thing. When I am talking about rust or rusting, we are only talking about iron, student. Till 8th class you all know about the rusting means it is a spoilage. No, it is not the spoilage of metal. Rusting means we are only talking about iron. When iron is reacting with oxygen and moisture, then we will call it as the rust. And the formula for rust is this, XH2O. This is dot means I have already explained, water of crystallization. When the any number of water, X means any number of water, will stick to this crystal, then it is called rust, which is reddish brown color. You have already seen the rust formation on the iron. Second example is when silver is attacked by the sulfide, that is sulfur from the air, it forms Ag2S, that is silver sulfide, which is black color compound, compound known as silver sulfide. That is why silver articles becomes black if kept open or after few days, especially during when rainy season or the polluted area. So silver sulfide. Question 2 marks in your board. An element X reacts with sulfur dioxide of the air to form the element Y. What might have happened? Yes, corrosion. Clear? Answer is corrosion. And what is the color of Y? That is blackish color. So this is the example of iron. This is the example of silver. Third, if I say, third is copper. Copper when reacts with oxygen of the air, it forms copper oxide. Again it is black in color. Again it is blackish in color. Copper oxide. That is why copper articles also becomes blackish in color if kept for few days in open air. Now suppose if I say copper when reacts with oxygen as well as moisture, then what happens? Or the carbon dioxide from the air, carbon dioxide. Suppose if I say carbon dioxide of the air, it is reacting. So it will form greenish layer, that is CuCO3 dot CuOH whole twice. Copper carbonate dot OH whole twice. This is the formula for corrosion product of copper. Two products can form possible, that is copper reacts with oxygen to form copper oxide, which is blackish in color, and when copper reacts with carbon dioxide or moisture of the air, it may form copper carbonate or copper hydroxide, which is greenish layer, which is greenish color. Clear? Another example, suppose if I say magnesium, fourth. Magnesium when reacts with oxygen, it forms magnesium oxide. Again, the originality of this property will change. That means in presence of oxygen of the air, it may form MgO, or the carbon dioxide of the air, it may form MgCO3, white color powder. These are white color. Question, 2 marks, board. C. Why the magnesium ribbon is cleaned with the sandpaper before the reaction? Because to remove the layer of magnesium oxide or magnesium carbonate, which is the corroded layer. So, what reaction could be easier? Right? So, these are all few reactions are there in your book, that is showing the what? Corrosion. How it can be prevented? Greasing, painting, oiling, galvanization. Galvanization, what is galvanization process? When an iron article, only I am talking about iron article, student. When an iron article is coated, galvanization, this is the term, galvanization. Galvanization. When an iron article is coated with zinc, then it is known as galvanization process. This topic again I will cover in metal and non-metal. There also will go with all these reactions. Right? Now the last topic of this chapter is rancidity. What is rancidity? Rancidity, student, if oily food like chips or any fried food which is there in your kitchen, what happens? It will react with the air, that is oxidation of the food, means it will react with air to gain oxygen and spoils that food. The foul smell comes, the taste also changes, that means the food becomes spoiled. That process is known as, or you can say the food is rancid. That process is known as rancidity. Mainly the oily food I am talking about, which is there. Clear? So oxidation. Question 1 mark. If the oxygen, high order thinking, if the oxygen is very important for life, then what is a harmful effect of oxygen? Rancidity. So oxidation of fried food is known as rancidity. Right? Now rancidity cause oxidation of food. How to prevent? Refrigeration. You can keep in refrigeration, then the air, oxygen from the air will not react with the food. Airtight containers, or yes, some antioxidant gases are there, which is low reactive and used as an antioxidant. Antioxidant means prevent the oxidation, that is nitrogen gas. So you can see chips packet, those are fried. So in that the nitrogen gas is flushed with. Means, question again, why the nitrogen gas is flushed in the packet of chips? What will be the answer, student? To prevent rancidity. Right? Clear? Any doubt? Comment section is there. Thank you so much for your subscription, your likings, your sharing. Thank you again so much for this. Keep going. That gives me moral strength. Clear? Thank you, students. Thank you so much.